Well, I guess let's get started. Laura Rowley's still logging in. Okay, well, thanks everyone for attending this webinar. We're really excited to have Ralph Wright here and listen to his expertise. Ralph has managed the Agriculture, Forestry, and Agriculture Economic Development's meteorological network since 2003. Over the past 19 years, his group has installed over 190 new weather network stations across agricultural areas around the province. To ensure the integrity and accessibility of the data, they have built a robust data quality control system along with public-facing websites that serve both historic and real-time weather data products and services across Alberta. Much of the work centered on the task of assembling all of Alberta's meteorological data back and forth and back as far as 1885. Ralph has a master's in soil physics from the University of Manitoba and a diploma in watershed management from Lethbridge Community College. He has worked extensively with meteorological data since 1993, producing several computer models as well as other products and services offered by Alberta Agriculture, Alberta Climate Information Services, found at www.weatherdata.ca. Well, thank you, Ralph, for coming, and we're happy to have you. I guess if we have questions throughout your presentation, can folks just type it in the chat box? Would you rather?
Sure, you bet. I may not see it as I get focused on what's happening, but feel free to interrupt me.
Okay, sounds good. I will do that. Okay, well, I will hand it off to you, Ralph.
Okay, well, thanks everyone for showing up. We've got quite a lot to cover here. I'll give you a quick overview of what we're going to do. We're going to look at weather data all the way back to 1884, try to find some patterns and trends, and I'm going to educate you on where the stations are in the province, how to get data from them, how we've assembled that data, and basically everything you're going to see today is accessible online, and it's a very wide ranging library of tools and data and lots of different things. And I'm going to hopefully you'll understand that it's really you have to be quite careful when you're using meteorological data and kind of perhaps take things with a grain of salt, and we're going to jump into that right away. So I'll get started. The first thing this is our website, but I won't get into that right now. I'm going to just quickly show you where all the meteorological stations in the province are. Here's Alberta. All those green dots are hourly meteorological stations that are operating today. There's almost 500 of them. But if we go all the way back to 1901, we've got less than 10 operating. So keep that in mind as we go through and look at some of these wider based trends that station density changed dramatically, and that can have a big impact on what you may think you're seeing. Another thing that's quite important about meteorological stations is they all have personalities, and there's been different standards applied to them throughout the years. Measurement technologies have changed, land use around them has changed. So you really got to wonder whether or not you are truly measuring the same things that you were in yesteryear as opposed to today. And today is even a challenge. I've got a photograph of a meteorological station here along the Milk River Ridge. And for probably 5 years or so, I've been noticing that the maps are showing a bit of a high spot, more precipitation than normal, or not normal, than I would expect based on the surrounds. And it was on a ridge top, so I thought, well, okay, maybe the high ground is catching the snow. Well, the technician sent me a picture of this site just a couple weeks ago. And I'm not picking on this site, but this is, this happens in a lot of times. You just really don't know where things are. So this is their station. The snow, the precipitation, which is rain and snow, has been high at this site. And the minute I looked at this picture, I realized instantly that this was a bit of a snow catch. We're now looking southwest. The winds are predominantly westerly. They're being slowed down by these trees. Here's the precipitation gauge here. and it's catching more snow than it actually should. And this was just kind of an eye-opener for me. It was, I'm glad I saw it in some way, but all of this data pours into the National Archive. It pours into our data sets. And this is not just a one-off. It is, the tip of the iceberg. There's probably maybe 5%, 10% of the stations that are not sited ideally to different extents. So it's important to realize that as we look at some of this data. Now, I'll dive a little bit closer. This is an example. This is that same station, and this is a graph generated by the website. It's down here at Milk River Ridge. What we're looking at is about a month of daily temperature and precipitation data. And what we see here is the temperatures, actually it's not a month, it's just several days. Sorry, that's the next one. The temperatures at the two stations are represented by this line. We have a 0 degrees Celsius line here. And what I'm trying to demonstrate is how this station responded once it started to snow. So precipitation at both the stations is tracking nicely. The station in question is the black line. And we can see, it's measuring more, but we're quite a bit of distance away, maybe 30 kilometers or so. But the minute we cross a 0 line and the snow started, things started to drift upwards. So much, in fact, that, nearby we got 35 millimeters of precipitation, and just in the space of a couple days, this one was measuring 55. So how do you know that? By looking at the data? You just simply don't. Here's that another broader look at this. Now this is about a month. This was the event in question. I've picked several more stations in the area to give you a comparison. Tracking nice, cross the 0 line, and we see the snow coming up. Again, here's a 0 line, a precipitation event, and a bunch of snow. Appearing to be catching snow. The interesting thing is, if we go and look at the entire season, again, the station is black line. So this is June, July, August, and September. We can see that generally these stations, the station in question, 282 millimeters, and another one nearby had 282. But one thing important that this graph is showing us, we're working in a fairly small area, south of Lethbridge here, and we've got quite a bit of variability just spatially in the precipitation. And that's important to realize. We see stations in around the city of Edmonton where there's 5 or 6, and over a year they can vary by 75 millimeters or 20%. So station siting is really important. And as we try to assemble data from different stations in order to get the 100-year record, stations exist for a period of time and then they go away or they get moved. So if you're trying to do 100-year comparisons on station data per se, you would have a very difficult time because you're going to find that the information's quite fragmented. So what we do, and we'll look at this soon, is we go to every township center, we look around digitally for the stations that reported on any day, and then we weight the observations for that day. So when a station goes offline or gets moved or completely disappears, we don't have a gap in the record. And this allows us to then see these longer term patterns and trends. Perfect example is Athabasca. So I've got almost 100 years of records for Athabasca. This is a listing of all the stations that existed in and around Athabasca influencing that record. And we can see, in 1918, they had a station that ran to 1967. They had another station 1900 to 1927. And then throughout the years, various other stations that operated for various times. And in fact, today, there's only 2 stations up to 2022 operating. But all of these stations and all their different locations will be going to help color the meteorological record. And that obviously would introduce some errors. Where was it sited? Was it near the trees? Was it kind of on lowland, highland? All that kind of stuff. So keep that in mind as we go look. And I'm sure everyone's looking for, climate trends. And the data does show all sorts of interesting things, but remember, it's not perfect, especially since it's such a long period of record. So we're going to change gears a little bit here and look at a series of maps, and we're going to go all the way back to 1901 now. And each one of these maps is a year. And they show us that during the early part of the century, up until about the 40s, it was quite a bit drier than it was now. And then we went through a wet period, mid-century wet period, actually even cold as well, colder than what we see today, and arguably colder than what we saw earlier. And then about 2000, we hit a bit of another step in the meteorological record, and we went to somewhere in between what we saw with respect to precipitation in the early part of the century and the mid part of the century. So it was dry early on, got wet for about 50 years, and now it's kind of somewhere in between for the last 25 years or so. So I'll explain what these maps are. Each one is a yearly precipitation total relative to the long-term normal. So this pink here, look at this scale, the driest once in 50-year dry year. So if you got a pink area, it's only happened twice. You've only had a year like that twice. And on the other end of the scale, we have a once in 50-year wet, and then a grade all the way in. Green is generally near normal. So the more blue and purple you are, the wetter it was. The more orange and pink you are, the drier it was. And why is this important? Because we can look at 2021 or any particular year and get a sense of what that year was relative to the normal. And everyone's very sensitive to that these days, you know, thinking about weather over the last few years. And, you know, is this a trend? Is it a pattern? And one thing I'll say, even me, I've looked at a lot of data. It is, you know, and I look outside and I realize how short my memory is. So these maps are really great for kind of really putting things into context. So 2021 was a very, very dry year. It's right here. Most of the ag areas suffered greatly. There was that heat dome that came through at the end of June and really caused trouble for agriculture. And at the end, a lot of the times we heard the words unprecedented. You know, it was an unprecedented year. And we can actually go take a look and see how unprecedented it really was. Certainly from 2010 to 2021, it was unprecedented. In fact, southern Alberta had that dry spell right on the heels of about 5 years of pretty dry weather. So it was quite impactful down there. So now let's go think of this graph here, this map where we see all of this pink and all of this orange, very, very dry, and see what that looks like back, compare those to 1901. So this is a map of 1902 to 1913. We take a look back, and in generally we see a lot of dry on these maps. So this was a relatively dry period, and arguably maybe 1905 was as dry. But look at these maps here, and you'll see that they're quite angular and whatnot. This is really the lack of weather stations we had back in those days. So it's difficult to generate accurate maps. So I just sort of look at this set, and it doesn't tell me a heck of a lot. I'm not too confident in it because there just wasn't a lot of stations. But in general, I can say, yeah, it was pretty dry over that 12-year period. Now, we're going to jump into the next 12 years, 1914 to 1925. And I got 21 as a bit of a, you know, a memory marker here for us. And we can see 1917 and 1918, certainly very dry years that arguably would have rivaled that one. And just a few years later in 1922, it rivaled that one. Now I'm going to bring your attention to something else that's very important about these maps too, and that's the spatial variability we see. Look at 1915. We had 1 in 50 year wets down through the central parts of Alberta, where you guys are, and not too far away we had 1 in 50 year dries. And you'll see this time and time again, year in, year out, that these dry areas and wet areas are co-located. There's very sharp boundaries. So when someone says 2021 was a dry year, you know, it depends where you live. You can't just say that for Alberta. Look, we had some 1 in 50 year wets up in the forested areas in 2021. So we got to be careful in terms of making these very broad generalizations. So now let's wind forward into the 30s. This was 1926 to 1937. We see a few more wet years popping up, but in general, quite dry. Another rival year to 2021 in 1929. And let's go another 12 years, and I've taken that map off because it's no longer really relevant. Maybe 1958 was a pretty dry year, but I don't think quite as dry as 2021. But look what we see here. We start to see a little more blues and greens creeping in the 50s and persisting through the 60s. Bit of a dry area here. Now this is where it gets really interesting. And this is where most of our lifetimes, at least in the working world, begin. You know, some of the young, you know, in terms of older people still in the workplace, such as me. I was born in 63. This is where our memory really begins. And arguably, you might have to question whether or not our memories are very capable of going back this far. But anyway, 62 to 73. Look how wet this period was. So really the taps turned on. It was quite cool during this period. In fact, in 74, Maclean's released an article talking about an ice age coming. Quite wet. Now we go another 12 years and we're now up to 85, still wet through the 70s, very wet through 84s. Agricultural systems are beginning to evolve. Cities are starting to grow. Infrastructure starting to be planted, all based on these sort of meteorological records for engineering purposes. But you got to ask yourself, you know, was this normal? Is it normal? Is this a long enough period of time? Last 30 years, typically this stuff is done to really get a handle on what climate is and what kind of variability we might expect. If you had if you built your cottage on a lake in 84, your lake could have been very high because you've had quite a few years of wet weather. And that is normal to you, that lake level. But the reality is, what is the range of that lake level over time? So let's go another 12 years. Again, wet, very wet in 96 in this part of the province, still wet, wet, wet. So now we've got about 50 years of all these nice blues on the map. And then we turn the page into the new millennia and things are drying out. And it pretty much starts in around the 2001 drought. 2001 was very bad in southern Alberta, and 2002 was considered to be unprecedented in many areas of the prairies. But interestingly enough, it wasn't very far away. Southern Alberta, if you told them 2002 was a dry year, they would scratch their heads and say, what are you talking about? But if you talk about to a lot of farmers on the prairies, many would agree. So you got to be careful again in making these broad-based assertions about whether it was dry or wet. But in general, you know, we're fairly mixed now. This is 98 to 2009. 2009 was a nice drought year. And again, we're now going to go 2010 to 2021. Again, some, you know, good mix of wet and dry years, but certainly not quite the persistent dry we saw at the beginning of the century up until about the 40s, transitioning into a wetter period through the 50s, and then wet 60 right until 97, now somewhere in between. So that's quite interesting. Any questions at this point? Maybe I should just carry on. Now I'm going to show you a little bit more. So these maps have given us an impression of what it was like. So, you know, and I'm going to show you a couple graphs that kind of help us to understand that maybe we shouldn't be making impressions on one thing alone. Let's go to Calgary. So this is accumulated yearly precipitation at Calgary from 1885 all the way to 2021. So the height of these bars means a wetter year. This red line's an average line. And this is Calgary. We get a bit of a different impression here. Wetter at the first half, drier at the last half. So it didn't quite follow the pattern, and maybe you don't want to walk away with, I guess what I'm trying to say here is if better look at the area rather than a big giant picture like Alberta. But this tells us some interesting things here. The wettest year was 1902, 850. We haven't seen anything like that since. The flood of 2013, I believe it was in Calgary. Was it 2013? Anyways, it doesn't even show up on this map because that was just one event that didn't really impact the annual total. But what we see here are some of the recent droughts in Calgary, but they are paling in comparison to some of the other years we had. And you want to talk about variability. The driest year ever was in about 1893, And it was only a decade or so later where basically the heavens opened up. We had the wettest year ever, bracketed by several wet years. And one may say, looking at this trend, oh, it's getting wetter, 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 wetter. Okay, well, you know what I need to do? I need to adopt some practices because the weather is going to get wet. It's going to stay wet. Well, look what happened just as you got a handle on this nice trend. Boom, it dropped down into the dry times that we had in the 30s there. And then, maybe again, you're going to say, well, it's really dry. We need to do a bunch of stuff. But Mother Nature had different designs and went into another series of wet years. And basically, you really don't know what's coming. All we can do is look at this record and say, wow, it's been quite variable. There doesn't appear to be any real trend or pattern. And if I do get a trend, they quickly reverse. That's really important to know. Now, Calgary has enjoyed some pretty good wet years in the last few. So those people down there sort of calibrated in their minds to this sort of weather, but anything could come to them. So that's kind of Calgary's story. Let's look at Edmonton's story. We can't say the same things about Edmonton that we do about Calgary. In fact, Edmonton's drier in more recent years. Kind of our heydays were the 70s through to the 2000s. Lots of moisture, lake levels up high. But one thing that they do share is this crazy part of the first century where we had two of the wettest years ever, followed by some of the driest years ever. And some of these nice descents into dry and nice ascents out of wet. But in general, no real bankable pattern. Okay, so that'll give us sort of an idea of what we're going to look like as we go through some of the more historical data. And, if we're going to focus in on Lacombe, don't take that home and say, this is what our weather's like. If you live in Edmonton, you have to look carefully at Edmonton or even just a couple 100 kilometers away, like those maps were showing us. It's incredibly variable over very short distances. And Alberta's a particularly complicated place for that because we've got plains, foothills, and mountains, and that does all sorts of strange things to the weather patterns as they're steered around by the topography. So let's jump into the website. So how do you get all of this cool stuff? You go to the Alberta Climate Information Service. You type in weatherdata.ca. I'm just going to do a check. How are we doing? Is everything working fine?
Yeah, everything's been going really good so far.
Perfect. Okay, so here is our website, weatherdata.ca, or just type in Alberta climate data and you'll end up at a site that looks like this. We've got all sorts of tools here. I'm just going to scratch the surface. Cool dashboards for current conditions, weather station data, hourly and daily, all the way back to 2008 for hundreds of points on the landscape. Maps. You can make a map of the frost overnight. This is a good example. Anything blue froze. So if you're farming and you're wondering, do I have to worry about frost? 20 at my field's 20 kilometers away. You can quickly get an idea of what the lowest temperatures were, or highest temperatures if you're worried about blast in your crops, heat blast, things like that. Weather radar, beautiful overlays on Google Maps. You can place 6-minute slices up to the last 6 minute, zoom into your house and see where those clouds are coming. Great party trick when you're doing a barbecue and it's looking like it's raining, people are worried. You can pull this up on your phone, take a look and say, yeah, it's gonna last about 20 minutes and then it's clear after that. Or maybe you see it as long bank of rain behind it and it's moving towards you. Well, then it's time to just sort of pack up and you've got 30,000 maps. So if you need a climate map for presentation, all the way back to 61, snowfall, precipitation, temperature, soil moisture, you name it, we got it. Climate normals, we're going to look at those, compare the early 61 to 90 normals to the more recent 91 to 2010, 2020 normals. Historical weather data, daily all the way back to 1901 if you want to try and find some of the patterns that might be affecting your operations or look at some of the extremes so you know how bad has it got, how often does it get bad, things like that. And finally, a nice mobile web app, which we'll take a look at if there's time, which is what you should all put on your phone, because this is just so, it's a wonderful thing to see what the temperatures were. We don't just tell you what they're going to be, but we've got nice records back a month, and you can go check all sorts of neat things. So let's first dive into the weather station data viewer. How do you get meteorological data, and what kind of meteorological data do we have for you? So you click on that, it loads up, and you're greeted with a map with a bunch of dots. You have some tabs here, popular elements, derivatives, so many check boxes. You can get over 100 different things at many weather stations here. Temperatures, precipitation, humidity, wind speeds, corn heat units, potato heat units if you're growing degree days, frost probabilities, lots of things. Down here, you can do it for different periods, daily, monthly, hourly. You can pick your dates and then go at it. So let's start. I'm going to zoom into Edmonton right now because this is going to make an interesting point about meteorological station. Urban heat islands, really important. So we've got Edmonton station in Edmonton. We got one out at the international airport. I want to go take a look at temperatures. I want to go take a look at the hourly temperatures over the last month. What the heck is going on here? It's complaining. Why is that? Okay. So let's take a look at how warm it is in the city versus how warm it is out in the country. I've just plotted a graph. The black line are the city temperatures. The valleys are typically the nights. The peaks are the days. And we can see that, wow, it's getting quite a bit colder out in the country. So as the city grows and we continue to make averages and normals and things out of the meteorological record, or if you're exploring the historic data we're going to go look at soon, just bear in mind the cities have a big effect on things. In fact, so does land use in general, and that's quite difficult to quantify over the last 100 years. But again, look how much colder. On this particular day, this is a neat graph because you can just sort of hover over, get your tool tips, but the international airport said minus 26.5. The city station said minus 21, basically. That's 5.5 degrees difference. The other thing that's really neat about these graphs is you can, we're a little bit slow, you can scrunch them down here. It's not happening. And then move them side to side, and you can actually kind of scroll over these charts and get a much closer view of things. So with this urban heat island kind of idea and meteorological station in mind, you got to think going back 100 years, what did the landscape look like? I'm going to throw a satellite image here on, and this is Edmonton again, but here's this dark green is trees. This represents some of the cleared land. We can actually zoom out, take a wider view of the province. We see a bunch of cleared land in the piece. So when was the land cleared? How did it affect the meteorological observations? That's something you got to keep in your mind as we go very far back. Let's just zoom in to Athabasca. And to prove that those light areas are indeed farmed, you can see all the little farm fields in there. The dark areas are green. So keep that in mind too as we wander back through the meteorological record. So let's take a look at
Ralph, we have a question. Can we have a time for a question, Ralph?
Yes, sure.
Just while we're on the topic, is there much for wind data, and what does wind speed at 2 meters mean?
Okay, yes, there's quite a bit for, okay, that's you know what, that's a great question because I forgot to tell you guys something. I'm going to take this map view off. Great question. Is there much for wind data? Well, these viewers are interactive. So instead of playing whack-a-mole and trying to find a station that has wind by examining everyone, the minute you go hit a 2M wind speed, The only stations that measure 2M wind speed are left behind. Now, we have a section on the website up here, reference documents. It'll tell you all about what those are, but I'll answer that. That's 2 meters. So wind at 2 meter height versus wind at 10 meter height. And without going into too much detail, 10 is a standard height. We got to get out of the boundary layer, that i.e. the air is influenced by topography. It's swirled around by little hills. It flows down valleys, all sorts of stuff. So typically the higher the winds, the better. And with respect to winds, if you're looking for wind data in the mountain stations, you can just imagine some of the trees are pretty tall around the stations and they may not even be useful. This is going to lead us into another thing. If I want to take a look at the station, I click on it. All these boxes light up telling me what the station measures instantly, so I can pick all of those from the station. If I want to pick a few other stations, if you pick enough of these, some of these boxes are not going to light up, meaning that you don't have everything in all the stations that you've selected. Okay, so yeah, there you go. What was I going to say? I think I forgot. Sort of lost my train of thought on that, but yes, I know what I was going to do. Okay, so station, Gladstone. You click it, it comes down here. A lot of these stations have photographs, so you can go take a look at the meteorological station and its surrounds from 4 compass points. And you can see that this particular station is nice and out in the open. It doesn't have any trees. There's no big water bodies around it, so it's pretty trustworthy. The only thing is, with these high winds, they can sometimes lead to undercatch in the rain gauges, which is this thing right there. Hopefully you can see that. So lots and lots of tools we've given you to understand the meteorological data you're looking at. Elements is, so popular tab just kind of gives, it's the landing page. It's easy. You don't have too many boxes to look at and mess up your head with. The other thing that we have here, notice as well that these boxes are interactive with whatever period you take. If I pick daily, some of the boxes light up. So this is really convenient because I can go look at temperatures in Edmonton and I can look at the normal temperatures. Let's not do Edmonton, let's do you guys now. Let's go to Lacombe, CDA. That's close enough to Red Deer. Incidentally, the airport doesn't have a lot of data, so I just don't go there by habit. So temperature, how cold was it? How warm was it to normal? Let's go take a look. We are in daily. I can go all the way back to January for the year. Real quick year in review, especially if you're writing a report that's, you need to describe weather data. Sorry, I got January 31st there. Let me just get January 1, view it. And the black line is your normal temperatures. I'm going to make this bigger. And the blue line was what the temperature was. And we remember how cold it was back last winter, but it was interspersed with some pretty warm periods as well, but generally a relatively cold winter. We had a fairly warm start through March until April 9th, and then we had some really cool weather and generally, probably a little bit below normal. Once August kicked in, or actually this is July 7th, we can pinpoint that it became above normal, and it stayed above normal right until November 1st. So wonderful resource for anybody that wants to really understand what the weather's done, maybe the impact it had on their growing operations or anything else that they were doing that was highly weather dependent. The other thing we can do, so now that's just looking at meteorological data, but we can do all sorts of derivatives. You can add growing degree days on there, corn heat units for farmers, evapotranspiration. You can look at fire danger, dew points, even wind chills for sending your kid to school if you like. Normals. So now all of these measured elements is what we call them at stations, all have normals with them, so you can plot them relative to the long-term normals. Aprils. And the almanac is really cool because this says available for yearly only. We can go back very quickly and take a look at all sorts of things over the years. Air temperatures by month. So you want to look at what the last 60 some odd years of Aprils looked like. Here we go, 1961, view that. Did we have a cold April in 2021? The 22 stuff will be rolled in soon. But this is a good example of all the Aprils and all the variability we've seen. In fact, we had a period of fairly warm Aprils through 83 to 2006. And I'm going to caution you guys here too, because we're only looking at a piece of history here. And depending on the size of the piece you look at, can very well give you very different views. So the more, the better. And I'm going to tell you why. And I've seen this time and time again as people are, looking at meteorological data that may not necessarily have access to all of it, or maybe trying to make a point. But, oh, it's too bad my scrunches aren't working. There
Ralph,
we go.
Can this tool be used only for historical data, or can you use it to measure current data as of right now?
Oh, yes, sorry. All of those dots that you see on the map are reporting up to the last hour. So it's hourly, daily data right up until current time. They're all hooked up through the modern wizardry of today, and the data is constantly flowing off of them into our computers and then on to the website. So anyways, these graphs are interesting. We see a cooling April trend in general, one may argue here, looking at this particular frame of data. But if we look at another frame of data, we may not be seeing a cooling trend at all. Maybe we say that's fairly normal. And if we take just the right piece, we can even find ourselves perhaps a warming trend if you ignore these couple of years here. So be very careful when you're looking at this data and get as much as possible, because there are wiggles in these trends as they're bouncing around, and some of them may be false, some of them may be real. You don't know. And nice thing a meteorologist once told me is normal is just the number you get as you go from one extreme to another. And I thought that was just so amazing. So let's go take a look at real important one is last spring frost, right? Like what have they looked like over the last 60 years? So let's say -4 is going to be a frost that's going to kill your crops, or something you're worried about. Let's go take a look at those all the way back to 1961. There are, oh, sorry, wrong one. This is a slightly different graph. You can actually get a table and you can download all of this data as well. So right here we see June 9th was really the last, pretty much 1 year in 69, we saw frost persist of -4 at June 9th. But we had a period of time in here in the 70s where the last hard frosts were occurring pretty much before the end of April. But we had a really nice rising trend where it was getting warmer or colder. Yeah, colder, sorry. Where, the frosts were starting to persist longer and longer and longer, and maybe some worry was developing, and then boom, they pop back down again. But in general, this is the trend that we've seen with spring frosts at Lacombe over the last 60 odd years. So you can explore lots and lots of different things there. I'm going to move into another area, and we're going to go look at the interpolated weather data. Now, this is for every single square on this map. We've assembled weather data from all available stations in the area using something called inverse distance weighting. So if the station's closer, it weights more to that value than the ones that are further away. And this creates these wonderful continuous time series that go back right to 1901. Again, there are various intervals, daily, monthly, yearly. These are all interactive with the legend. You'll notice if you look at your elements here, if you pick monthly, they change because there's different roll-ups, and yearlies change too because there's different roll-ups. So if you go pick a box here and then go change the data interval, you might go, what happened to it? Well, that's because you didn't specifically pick the exact same thing. So let's go take a look at air temperatures, average min over the last 100 years. And the map, once I do that, I've told it what I want, it's telling me that these blue areas have continuous data back 100 years. So let's go take a look at the province, and really that's our true 120-year meteorological record that one may consider to be reliable, not sort of mathematically manipulated and filled. A lot of people are doing that these days. I call it MIC data. I can give you a weather data value for every single place in the province down to the meter if I wanted to. But does it mean anything? The answer is no. So we've screened this out so it means something. So let's go to Edmonton, right in the city, because this is the continuous one, all the way back to 1901. And we'll go to our interactive graph. And these are the yearly minimum air temperatures. Now look at this. What do you see? You see quite a dramatic increase, and in fact, possibly a leveling off. But again, we need to caution that after looking at a lot of this data, you will find that the current patterns may not be fully repeatable. It's kind of like the stock market. It's very difficult to predict. There's rapid reversals, but this is interesting because this is a city station, and there's been a lot of development over the years, over the last 120 years. I guarantee you it was not the same place it was back here compared to here. And we don't have to go very far outside the city. So we are going to conclude, off that graph that air temperature has been in minimum air temperatures. I could draw a line through these points, has been increasing by some statistical amount. Fine. Okay. Now look at if we go to the airport, not very far away, we have a completely different conclusion to come out of that. And here is that mid-century cold spell I was telling you about. We didn't necessarily see that in the city, but this particular station is showing it. So I'm going to strip that off and let you guys all kind of ruminate on this particular graph for your 120-year minimum temperature outlook. And there's another interesting thing here too, because urban heat islands, we often hear it's warmer in the city at night. Well, let's go take a look. So we see, I'm going to put this back. And I'm going to, maybe I'll just strip this one off. So here's the minimum temperatures to refresh your memory in Edmonton City. All right. What about the maximum temperatures? Let's just take a look at those alone. The maximum temperatures haven't done the same thing, and that's because typically the sun can only heat up the surface that much, and it's the mins that are really affected more by buildings and lack of vegetation and all sorts of stuff. So two different pictures at the exact same stations, choosing two different variables. We can even go take a look at something like, the highest temperatures measured in any year over the last 120 years. And there they all are. We had some pretty hot temperatures way over here. Here is 2021 with that heat dome way over there. Looks like we've had some similar years in the past. Just for Edmonton again, Edmonton City. So again, we have to be careful. So now let's zoom straight into where you guys are and take a look at what the air temperatures are doing there for the mins. And 1146. Sorry, I need to strip off this guy. We're polluting it. So a great place for you to go see what's happened in your particular neck of the woods over the last 120 years. And just for fun, let's just throw in the max temps. And there's the max temperature. Different story again on the maxes, right? It's quite interesting. Okay, so the other thing you can do too is look at snow. How much, what are the snows like? So this is modeled snow precipitation total. So how much fell as snow over the, in any given winter? We can see that, we've had some pretty big snow years. In fact, if you're a betting person, it's probably not unreasonable to be planning for snowfalls like this, years like this. Just because we haven't seen it in so many years doesn't mean it can't happen again. And this is where this data becomes really powerful, is because it really gets you out of your frame of reference, which might be in here. Or if you're just getting a little bit of meteorological data because it's too much trouble to assemble, sticking in here. Well, this gives you a completely different view of the world looking back further. But we do see snow totals have tapered off. And in fact, we can even look at snowpack depths, maximum depth of snow, because this will include some of the melting. And we can see that we used to have a lot deeper snows back in the olden days, when the old folks are telling you they were going to school in 6 feet of snow uphill both ways and it was minus 30. That's absolutely true. This shows that. Okay, so I'm going to switch gears one more time here, and we'll take a quick look at normals, because this is important. So here's our climate normals. This is kind of neat. I'm going to go select a station. I'm going to select a station. Yeah, okay. And again, let's go to your neck of the woods. There we go. Close map. Now, lots and lots of different things. We've got these various normals. So these are 30-year averages for whatever start date you want. Let's say January to December, and so many different things. You can look at precipitation patterns, temperature patterns, growing degree days, heating degree days, lots and lots of different things. Even solar radiation, if you're sort of planning, to put solar on your house, you can go and investigate that and even compute with this data by downloading it, how much energy you may get or may not in a particular year, and what is the variability thereof. So this is a good one. 5-day precipitation normals. So these are really going to show us what our patterns are in a year. So each and every day, what was the last 5 days averaged over the last 30 years? So January 5th, basically that's January 1 to January 2 to January 5, all averaged up over the last 30 years. And we can see that we get a bit of a snow hump recently in January. So end of January tends to be snowy. February, not so much. We tend to get a fair amount of snow dumps in early March, and another big snow dump at the end of March. And lo and behold, the May long weekend. So these are showing us sort of the statistical patterns in the rainfall. Do we have wet weeks, dry months, or dry periods? Great for haying and stuff like that, because this is telling us that, there tends to be a lull statistically. And if you're, if you're playing the odds, this is when it's most likely to be dry in the summer. And this is the wettest time of the year. Don't plan your wedding in here if you want an outdoor one. Maybe shoot for in this particular period. That's kind of neat. So this will also show us how some of these patterns may have changed. I can throw 1961 on there, and we can take a look at how these patterns have changed. And what we're seeing, I'm not going to get into it, but when we look at temperature changes, annual temperature changes, what we're mostly seeing is the winters used to be colder and snowier, and generally the summers aren't that much difference in temperature and in most places. So when we think about the traditional thoughts of the planet warming, or even in your particular local area, everyone goes to growing season. Well, you can actually go and investigate what's happening, and what we're typically seeing at most places that the growing seasons aren't too different. If anything, some of the frosts may be coming, the fall frost may be coming a little bit earlier now, and the spring frost just a little bit later, which is counterintuitive. This will show you all that too. So Yeah, lots and lots and lots of different stuff here. I guess I will just quickly prove to you what I said. So let's go to the air temperature mins. We're going to generate our graphs. And so the black line is now, and we can see that it used to be colder in the winter by the blue line. Not a heck of a lot of difference through the summer. And, you know, looking a little harder at this, you can start to pick out some interesting trends, like the falls lately have been a little bit colder than the falls back then. But again, you have to wind this all back and ask yourself, what does that mean? Because I've seen these big reversals in the past. So do I really want to be banking on, you know, 30-year normals? And we can go back to the almanac if you really understand this stuff and go get those 30-year normals and look at all the yearly variation, and maybe just a year or two is driving them. So I think I will leave that for now, because that leaves us 8 minutes for questions. I just maybe want to show, oh, I think I got rid of that. So let me just show one more thing, because this is what you should all put on your phones. Where are we? Oops. So mobile web app, I will, yeah, so there's a mobile web app. It's also an icon on the screen. This is really neat. It'll format to your phone once it loads. Okay, so I'm gonna pretend this is a phone. I'm gonna scrunch this down. It's gonna reformat to your phone and look something like that. That's really cool. So every day you're greeted with this. It's now at 11 a.m. Edmonton, it's too bad it's yours. It's not where you guys are. It's 18.2. I can click on this and see what the temperature's been doing over the last several days. And I can even go back and take a look at what the temperature's done over the last month. And if I want to add precipitation there, I can throw on precipitation and I can see what days it rained or snowed or whatever it did. So this is just a wonderful application to put on your, it's what do they call it? Mobile friendly web site. So it looks like an application. If you simply bookmark this on your phone and move it to your home screen, it looks like you have a weather app, but it really isn't. And all the forecasts are here. Lots and lots of different things. You can get weather radar on here and cruise the weather radar last 10 minutes. You can go all the way back to 61 for some things. You can get weather forecasts, weather alerts, lots and lots. So I'll end there and we'll open it up to questions.
Well, thank you, Ralph. That's a lot of information in one session.
Sorry.
It's great though, but I just wanted to mention that we are recording this. So if you do want to go back and rewatch the webinar, just go to Lacombe County's webpage and you can rewatch or send it to whoever you'd like. Sure. And thank you so much, Ralph. We really appreciated having you. Is there any last minute questions from anyone or any quick topic anyone wants covered?
So, Jillian, I have a question if you don't mind, please.
Sure.
Yeah, thanks very much for the presentation, Ralph. I found it to be extremely informative. And obviously you're the expert on weather data in Alberta, or one of the experts. And just based on your knowledge of the weather changes in our province, I'm wondering what your thoughts are on the concept of global warming.
Oh, they're like everybody else's, right? I just wish we had more meteorological data, because I think that would put a lot of frame up on stuff. So, yeah, I see it in some of the data and I don't see it in some of the data, but then again, I understand a lot about how the data was assembled. I've seen a lot of different weather stations. So it's I don't think you're going to get a definitive answer here if you're looking for what side of the fence to sit on, but I think you will certainly get your eyes opened in terms of you know, some of the reporting you may see, and put things into, you know, more of a longer term perspective.
Okay, thank you for that.
Is there any other questions? No? Okay, well, thanks so much, Ralph. We
Yes,
really
and
appreciate having you.
okay, and I just want to let you guys know, you probably your heads may very well be swimming because you saw so much. But my phone number is right here on the bottom of most of the viewers. So please feel free to phone me if you're getting a little confused or, spent 5 minutes and can't find what you're looking for, because I guarantee you here, I didn't even show you the maps and several of the other things. So I can lead you to the water quite easily, as it were.
Is it okay, Ralph, if we post a link to your website on our website and then
I
make
would,
it easier
please
for
do.
folks? Okay, we
Please
can
do,
definitely
that would be
do that.
fantastic.
Sure. Okay, we'll do that. Yeah. On the Lacombe County website in the agricultural department, we will post a link and you guys can find it quite easy through that route.
Perfect.
Great. Well, if that concludes our webinar, and I hope you, there's so many cool things you can do with that program. So hopefully you guys check it out. And thanks again, Ralph. It was a very informative session.
Okay, take care. Goodbye, everybody. Thanks for joining.
Okay, thanks, everybody. See you. Great. Well, thanks so much, Ralph.